Hello, everybody. Glad to have you once again here. Now, this time we're going to have a very quick discussions on best practices in AWS. The intention of this session, like what we exactly wanted to understand from here is what are the best practices are expected from Amazon Web Services and how those best practices can be beneficial in deploying our application or architecting one application, how they called it, architecting an applications into AWS cloud. So this is basically something, if at all we are expecting to have a comparison, like whether AWS is better than IBM Bluemix or AWS is better than uh, uh, any other services like Google App Engine or Microsoft Azure or something. So no, that is what we are not going to discuss here. We are trying to see what AWS has to offer and what is going to be best in that. So this once again relates to your subject syllabus. Okay, so let us try to go ahead and see what is it all about. Starting with AWS, we all know it stands for Amazon Web Services. What all we offer under that, there are multiple different services we have. There are a few very advanced services and there are some primitive services. There are primitive services where I can deploy a simple applications and run, which is called Elastic Compute Cloud. I can have simple storage solution, which is called S3, where I can store my file. It is nothing but a simple storage solutions. I can also have something called RDS, Relational Database Services and all. And there are some very advanced services and as well, where I can have something called Deep Lens. And I can also have some other very primitive ML machine learning services. I can have some AI services where processing of my AI codes can be better. So that is all about AWS in short. Now let us see if at all I have one application and I am trying to deploy that particular applications on a data center where this data center runs on Amazon Web Services. Then how does that gonna be giving me any of these benefits? Okay, it is obvious to understand that in the last video also we were discussing there are two type of costing models what we have. One is called CapEx and the second one is called OpEx. The capacitive costing or the capacitive expenditure is the initial cost to set up the infrastructure, and OpEx is the operational cost to run any of the businesses. So if at all I wanted to design or develop an application, so that will all come under my initial CapEx. And if at all I wanted to deploy the applications on the cloud server, so for every day, for as per my usage, how much I am paying for that deployment, those are all gonna come under the operational cost. So here, first thing first, obviously I'm gonna talk about these two aspects. These two are definitely the benefit. The first benefit goes into it, and there is no upfront costing involved if I have to develop and deploy my applications on AWS. Because as we already know, there is something called DevOps. We're going to have a different video where we're going to only talk about DevOps in detail, but as of now, only a very fundamental part that DevOps helps us to design two set of infrastructure. One is for the production, one is for the development. So for development, whatever component I'm gonna design or whatever the application I'm developing, for that I'm gonna have an infrastructure ready, some set of servers and everything. And as that particular requirement is keep on changing, like after designing 3, 4, 5 different functional components or something, if I have decided that no, I need to increase my RAM a little more, I need to increase processing capacity a little more, then those all changes can be at the same point of time configured for my development and as well as for my production server together. So that is nothing but development and operations put together. So for this kind of cases, I can rent my services from Amazon for my production as well as for my development. On my development server instances, I can go ahead and configure and I can perform all my operations on that. So there is no problem in that. So initially there is no upfront costing, as it says. Right. The second is JIT. JIT stands for just in time. Just in time always refers to a situation where it is very much required and I want to have the infrastructure ready. If at all it's a non-cloud or non-AWS kind of an environment, what I'm supposed to do is I supposed to go to a market, I supposed to call for multiple quotations, I should buy the server, I should install the configurations, whatever is expected, like the software, the firmware, the drivers, and then it can be made it running. However, in case of any cloud service provider like Amazon Web Services, I can get that infrastructure done in just in a time, just in a matter of few couple of minutes. Right. The third primary advantage goes as the resource utilization. Now, what do you mean by resource utilization here is, in some of our discussions during our classroom sessions, we have understood that if at all there is an applications available, for that applications, the requirement can go high or the requirement can go down. Requirement in terms of demand. Like the demand can be for 500 users or for 5 users at any given time situation. Now, if at all I have configured my application for 5 users, then definitely I'm not going to not able to support rather when the requirement or the request from 500 user comes in. And on the other side, if at all I have configured it for 500 users and maybe for 70% of the time only 5 users are getting connected to my application, then there is a huge potential loss to the infrastructure where I have invested for. So that is not what really is expected for. So what we do, we go for and call it a elastic compute, where based on elastic property, like if at all I drag the infrastructure requirement demand high, it's gonna increase. The moment I leave it, if at all this all 500 users get disconnected and only 5 users get connected to that, automatically the requirement comes down. So that is the elastic property of most of these cloud service provider, specifically in Amazon Web Services. And obviously connected to that, it will be the costing. And the very popular term in cloud computing, we call it, all of us know, we call it pay as you use. So it's obviously whenever for, if at all, the example can be taken, brought into picture in a very specific situation. Say my client requirement is something like at T1 time instance, I have got 5 users. At T2 time instance, I have got 100 user. At T3 time instance, I have got 500 user. And this one is like T1 lasted for 10 minutes, T2 lasted for 5 minutes, and T3 lasted for 3 minutes or something like that. So now when the billing part comes to a reality, I will be paying for 5 user requirement for 10 minutes, for 100 user infrastructure requirement 5 minutes, and for 500 user infrastructure requirement 3 minutes. So it is very much pay as we use, as I use, as you use. So that's the costing part which comes into picture. Specifically saying in Amazon Web Services, the billing is very, very prominent. I'm using it for a very long time, almost like 6 years now, on a very regular basis for my research and for my other works. And the billing is really very, very perfect. Yeah, and the final component comes when we call it reduced time to market. Now, how do you actually define that one? Is like, it's very triggered to understand that there are 2 types of computations which is actually governing the complete industry now. One is called sequential computing, and another one is very popular, is called parallel computing. Now, in case of sequential computing, we know the instructions or the programs are written in such a way that it's supposed to go line by line. And I have to, if at all I have 100 lines of code written, I should start from the first line and then I should proceed to the 100th line slowly, one after another. I don't have an opportunity to jump in between. In case of cloud computing, as the complete infrastructure is made on instances are nothing but the CPUs or the virtual CPUs, vCPUs rather, what we call on cloud instances. It actually encourages us to write the application in a parallel fashion. So what I'm gonna do is, if at all I have this 100 lines of code once again, I'm gonna distribute that code into say 10 parts where I'll have 10 lines of each code to be executed. So this is nothing but my lines of code, and I'm gonna run it on 10 CPUs in parallel. Okay, or we can call it a virtual CPU, vCPUs. So this 10 lines of code will run on 10 CPUs. So that means this every 10 line will get executed in parallel, where 10 CPUs will execute 10 lines of code in a shorter amount of time. So if at all every line of code execution in case of a sequential takes 1 minute, and I have to execute 100 lines of code in a one after another sequential fashion. So my total time for execution is going to be 100 minutes. Whereas here, if I have the same frequency, so 10 lines will get executed in parallel. So for a total amount of time, I'm actually spending only 10 minutes. So the comparison is very obvious here. Where is 100, where are 100 minutes and where is 10 minutes? So obviously the time to get the code running or getting the result ready, or when I'm running a very big data analytics code, and if I am running a facial recognition applications or something, then obviously the parallel execution makes a lot of sense, and this is actually encouraged by Amazon Web Services and most of the other cloud service providers. Right, so that brings us to an end of the discussion where we can understand what are the best practices in AWS. So these are the 5 best practices what we have. Just a quick summarization: reduce time to market, costing as per the usage, resource utilizations are very efficient, the infrastructure deployment is very much efficient, just in time, and the upfront cost is very less and almost zero rather. Okay, we have to only pay to our customers. Right, so that's all what we have to understand from the best practices in AWS. Thank you for pitching in. Have a nice time, and don't forget to subscribe to the channel. Thank you very much.